Hello everyone, welcome to new class. Today's class is about the problems related to time response analysis. So let us go through the problems. First one is obtain the response of unity feedback system whose open loop transfer function is g of s equal to 4 divided by s into s plus 5 and when the input is unit step. So this is the open loop transfer function and it is given that it is a unity feedback system. So first of all we have to draw the closed loop system. So let this be the input R of s and this is the open loop transfer function g of s and this is c of s, that is the output, and it is given that unity feedback system. So this is a unity feedback system. So first of all we have to find the closed loop transfer function, that is closed loop transfer function c of s divided by r of s, which is the transfer function. So closed loop transfer function is, this is unity feedback system, so it is g of s divided by 1 plus g of s. So here h of s is 1, so we have to write g of s divided by 1 plus g of s. So g of s is 4 divided by s into s plus 5, then divided by 1 plus 4 divided by s into s plus 5. Now we have to take the LCM in the denominator, and this denominator and this one get cancelled, so we get 4 divided by, here taking LCM, s into s plus 5 then plus 4. Now we get 4 divided by, this is s square plus 5s plus 4, and that is equal to 4 divided by, and this we can factorize like s plus 4 into s plus 1, because multiplying we get 4 and adding we get a plus 5, so that is s plus 4 into s plus 1. So this is c of s divided by r of s, and we have to find the response. So response means c of s is equal to r of s into 4 divided by s plus 4 into s plus 1, and response means we have to find the inverse Laplace transform of this c of s, that is response is c of t. So we have to find c of t. For that we have to find the Laplace inverse of c of s. So here r of s is, it is given that unit step signal, so r of s is 1 divided by s. So r of s equal to 1 by s for unit step signal. So here we get 4 divided by s into s plus 1 into s plus 4. So to find the response we have to find the inverse Laplace transform of this function. So for that here we have to use the partial fraction expansion. So c of s is 4 divided by s into s plus 1 into s plus 4, and by partial fraction expansion, by partial fraction expansion we can write this 4 divided by s into s plus 1 into s plus 4 is equal to a divided by s plus b divided by s plus 1 plus c divided by s plus 4. Now we have to find the values of a, b and c. To find the value of a, multiply this C of S into the denominator of this A and equate this denominator equal to 0 and find the value of S. That is, here the denominator of this A coefficient is S. So C of S into S at equate the denominator to 0 and find the value of S. So here only S, so we can write at S equal to 0. That is, C of S is this 4 divided by S into S plus 1 into S plus 4. That is 4 divided by S plus 1, S plus 4, then into S at S equal to 0. So this S cancelled and we get at S equal to 0 means here we get 1, here we get 4. That is 4 divided by 1 into 4, that is 1. So the value of A is 1. Now we have to find the value of B. So to get the value of B, C of S into multiply with the denominator of this B value, that is S plus 1, and at S equal to, here equate the denominator to 0. That means S plus 1 is equal to 0. So find the value of S, that is S equal to minus 1. So at S equal to minus 1. And we get, so here multiplying with S plus 1, this S plus 1 get cancelled. So the remaining is 4 divided by S into S plus 4 at S equal to minus 1. So here at S equal to minus 1 means 4 divided by minus 1 into 3. And we get minus 4 by 3. So the value of B is minus 4 divided by 3. Now we have to find the value of C in this way. That is, C is equal to C of S into S plus 4 at S equal to minus 4. That is, here S plus 4 get cancelled. So the remaining is 4 divided by S into S plus 1 at S equal to minus 4. And we get 4 divided by minus 4 into minus 3. And that is equal to 1 divided by 3. So the value of A is 1, B is minus 4 divided by 3 and C is 1 divided by 3. Now put these values here. That is, in this expression put the values of A, B and C. So we get C of S is equal to A by S, that is 1 divided by S, then plus B divided by S plus 1 means B is minus 4 by 3, minus 4 by 3 divided by S plus 1, then C is plus 1 by 3 divided by S plus 4. So this is C of S and we have to find the inverse Laplace transform of C of S to get the response. So response means C of t. So response is C of t is equal to L inverse of C of S, and that is equal to L inverse of this one, that is L inverse of 1 divided by S minus 4 by 3 S plus 1 plus 1 by 3 divided by S plus 4. So the Laplace inverse of 1 divided by S is equal to 1, and that of 1 divided by S plus 1. So 1 by S plus 1 inverse Laplace transform is e raised to minus t. That is 4 divided by 3 into e raised to minus t, then plus 1 divided by 3 into 1 by S plus 4. The inverse Laplace transform of 1 by S plus 4 is e raised to minus 4t. E raised to minus 4t. So this is the response of the given system. And here if we want, we can take the 1 by 3 outside. Otherwise, we can write it in this way. Let us do another example. Measurements conducted on a servo mechanism show that the system response to be C of t is equal to 1 plus zero point 0.2 e raised to minus 60t minus 1.2 e raised to minus 10t when subject to a unit step input. Obtain an expression for closed loop transfer function. Determine the undamped natural frequency and damping ratio. So here the response is given and we have to find the closed loop transfer function. Also we have to find the undamped natural frequency. So undamped natural frequency is, we have to find omega n and the damping ratio is zeta. So here C of t is given 1 plus zero point 0.2 e raised to minus 60t minus 1.2 e raised to minus 10t. So here we have to take the Laplace transform. That is, on taking Laplace transform, we get C of S is equal to, the Laplace transform of 1 is 1 divided by S, then plus zero point 0.2 into Laplace transform of e raised to minus 60t is 1 divided by S plus 60, then minus 1.2 into Laplace transform of e raised to minus 10t is 1 divided by S plus 10. Now we have to take the LCM. So here LCM is S into S plus 60 into S plus 10. So here while multiplying with the LCM we get S plus 60 into S plus 10, then plus zero point 0.2 into, here we get S into S plus 10, then minus 1.2 into, and here we get S into S plus 60. Now here we can multiply. Here we get S square plus here 70S, then plus 600, then plus zero point 0.2 into, here we get S square, then plus zero point 0.2 into 10 is 2, 2S, then minus here 1.2 S square, then 1.2 into 60, that is 72, 72 S, then divided by here S into S plus 60 into S plus 10. Now after rearranging we get, here this is S square and here 0.2 S square, then 1.2 S square. So here 1 plus 0.2, 1.2, so S square get cancelled. Then here 70S, 2S, that is 72S, then here minus 72S, so S terms get cancelled. So the remaining term is constant one, that is 600 divided by S into S plus 60 into S plus 10. So this is C of S, and it is given that the input is unit step. So here unit step means R of S, that is equal to 1 by S. So this 1 by S is R of S. So we can write R of S into 600 divided by S plus 60 into S plus 10. So here we get C of S divided by R of S equal to 600 divided by here S square plus 70S plus 600. Now to find the value of So this is the expression for the closed loop transfer function. So closed loop transfer function. So this is the closed loop transfer function. Now we have to find the undamped natural frequency and damping ratio, and for that we have to compare this closed loop transfer function with the standard form of second order transfer function. So standard form of second order transfer function is omega n square divided by s square plus 2 zeta omega n s plus omega n square. So compare this closed loop transfer function with the standard form, and that is 600 divided by s square plus 70 s plus 600. So from here we get omega n square. Omega n square equal to 600 and omega n is square root of 600 and is equal to 24.49, and the unit is radian per second. So this is the undamped natural frequency. Undamped natural frequency. Now we have to find the damping ratio. So to find the damping ratio, this is damping ratio zeta. 2 zeta omega ns is equal to 70s. That is, we can write 2 zeta omega n equal to 70. So from here we get zeta is equal to 70 divided by 2 omega n, and that is equal to 70 divided by 2 into omega n is 24.49, and we get zeta is equal to 1.43. So this is the value of zeta, and this is undamped natural frequency, and this is the closed loop transfer function. And thank you for watching the class. If you like the classes, please like, share and subscribe my channel. And we will do more problems in the next class.